So welcome to Electronics Excel. So you are watching PYQ of signal systems. So we'll see in this video uh, the short questions of event semester 2024 and 25. Okay. So we'll see all the short questions that are 2 mark questions in this video. The first question is the differentiate between the continuous and discrete time signals. So we have to differentiate between the continuous time and discrete time signals. Okay. So let us check that. So it is continuous time and discrete time signals. So in case of continuous time, you can see there is one whose value exists for every instant of time. So every instant of time we have a value. But in case of discrete time, that it is defined at a discrete instant in time. Okay. So continuous times are typically represented by sine and cosine waves. Similarly, discrete time signals are usually represented by sequence of numbers. So we'll see in diagrammatically how it is represented. So continuous times have the value exists at every instant of time. Okay, and these are represented by the sine or cosine waves. Similarly, discrete time signals are the signals which the values defined at the discrete intervals of time, and it is the represented by the sequence of numbers. Okay, the continuous time signals are analyzed with the help of Laplace transform and Fourier transform. Similarly, the discrete time signals are analyzed by the help of Z transform or discrete Fourier transforms. Okay. Similarly, the continuous time have the infinite bandwidth because we are having the value exists for every instant of time. That is why it is at the infinite bandwidth. Similarly, discrete time signals have the finite bandwidth. The signals, that is continuous time signals, are represented by x of t. Similarly, the discrete time signals are represented by x of n. The continuous time described by the differential equations. In this case, it is represented by the difference equations. Okay. This is the examples of continuous time signal. This is a typical sine wave. You can see we have a value at every instant of time. In the sine wave, we have a value at every instant of time. So this is our continuous time signal. But in this case, we have a value at discrete interval. This is some interval of time. So 0, 1, 2, you can see. Now no values are defined between 0 to 1. Okay. So at 0 the value is 2. At 1 it is the 3. So this is the called the graphical representation of the discrete time signal. So this is the means difference between continuous time and discrete time signals. Okay. Second question is that state the Dirichlet conditions for Fourier series. Okay. So there exists the this condition is for the existence of Fourier series. The first condition is that the signal should have the finite number of maxima minima over a range of time period. Okay. So that should be a finite maxima minima. You can see in this example the maxima minima should be finite. Okay. So these are called the maxima actually. This is the called maxima. So maxima over a time period. This is the minima. Okay. This is the minimum. Okay. So this is finite. There is one over this over the time period 0 to t. It is one maxima and one minima. So this is the finite. It should be finite. Okay. It should be finite number of maxima and minima over a range of time period. This is the first condition for existence of Fourier series. Second condition is that the signal should have the finite number of discontinuities over a range of time period. You can see this discontinuous should be finite. Okay, you can see this is the time period suppose 0 to t. So discontinuous you can see there should be a finite. So this is from 0 to 1, then it is 1 to 0. You can see. So there is finite number of this is a discontinuous. It is discontinuous means it is the time when it is changing from 0 to 1 or 1 to 0. Okay, so that should be finite. So you can see this is the then 0 to 1, then it would be 1 to 0. Okay, so that should be finite. Okay, over a time period. Okay, so that should be finite number of discontinuities over a time period. Okay, the third condition is that the signal should be absolutely integrable over a range of time period. Okay, so over a range of time period, if we integrate the signal, that should be finite. So integration from 0 to t x of t, that will be a finite number. So if this is the x of t, suppose the signal is x of t. So if we integrate this over the period 0 to t, okay, that should be 0 to t, it should be finite. So it should be a finite number. Okay, and that should be finite number. So it is 1, 2, or that depends upon the amplitude. Okay, so this signal should be absolutely integrable over a range of time period. This is the third condition of the Dirichlet condition or the existence of Fourier series. So actually Dirichlet condition gives the existence of Fourier series. There are three conditions are there. Okay. So you need to write down the three conditions. Okay. Third question is that how to determine the time reversal of a signal. Okay, time reversal or time folding. So it is the this folding or reflection of the signal about the time origin. You have to fold the signal about the time origin. Okay, we can see over here. This is our x of n. So the x of n. So you need to find out what is x of minus n. So you have to fold the signal towards the time origin. So this 1 that will be minus 1, this 2 will be at minus 2, this 3 will be at minus 3. At this 4, whatever the amplitude is there, it will be at minus 4. Similarly, minus 1 it will be 1, that minus 2 it will be 2, minus 3 it will be 3. But we will follow the signal about the time origin. Okay. So this is the x of minus n. So it is nothing but the reflection or folding of signal about the time origin. So you can give some examples. Okay. So this is a 2-mark question. Okay. So next question is that explain the associative properties of linear convolution. Okay. So associative properties of linear convolution state that the order in which the three or more functions are convolved, it does not affect the final result. So let us see that. So the mathematically this means, so x of t you can see x of n convolved with h1 of n. First this 2 will be convolved, then it will be convolved to h2m. This is same as that. Then in case of x of n, first h1 of n convolved with h2n, then you convolve with x of n. So these two are same. Okay, this is called the associative property of linear convolution. This is in discrete time. So we can have the continuous time also, that n is replaced by t. So this is the same as that. So these are the associative properties of linear convolution. This is the for discrete time. This is for continuous time. Okay. Next one is what are the causal LTI system? Okay, so LTI means the linear time invariant. So a causal LTI system is the system where the output, that is the depends only on the present and past input, but it does not depends upon the future value of the input. So you can see this y of n. This is the, it will be the function of, you can see that output is function of x of n and x of n minus 1, that x of n minus 2 likewise. Okay. So it depends upon the present, this is the present value of input, this is the past values of the input. So it depends upon the present and past value of the input, but does not depends upon the future value of the input. Okay. So the LTI system is completely characterized by the impulse response, that is s of t in case of continuous time, s of n in case of discrete time. For causals, that will be impulse response must be 0 for negative values of time. Okay. So for continuous time, s of t equal to 0 for t is less than 0. For discrete time, s of n is equal to 0 for t is n is less than 0. Okay. So this is the causal LTI systems. Okay. Next is the distinguish between the autocorrelation and cross correlations. Okay. Let us check that. So autocorrelation and cross correlation. So you can see autocorrelation measures the similarity between the signal and the delayed version of the signal itself. Okay. Similarly, cross correlation measures the similarity between the two entirely different signals. So in auto, the same signal will be correlated, but it is a different signal in case of cross correlations. The autocorrelation is uses only a single signal. Cross correlation compares between the two distinct signals. So this is the, it is represented by RXXL. You can have the 1 point also. It is represented by RXXL because the two signals are same. Because one signal itself. Okay. Similarly, this RXY, that is the for two different signals there. So this is the, you can see this only the difference here is X, here is Y. Okay. So X is this that will be the Y. So two different signals are there in case of cross correlation. In case of autocorrelation, the same signal will be there. Okay. Next question is here, write the trigonometric form of the Fourier series. Okay. So the Fourier series of the trigonometric representation, you can see the Fourier series can be applied for the periodic signal only. So x of t is the continuous time signal is periodic with time period t, that can be represented as this one. This is the trigonometric form of the Fourier series. So a0 by 2, that is the summation of n is 1 to infinity an cos on n x of omega t plus sine n omega t. So you can see any periodic means continuous time signal that can be represented by the sum of means cosine and sine harmonics. Okay. So what is a0 over here? A0 is the, it will give the, it is the DC component. Okay. It will give the average value of the signal over the time period t. Okay. and this will give the amplitude and frequency of the cosine harmonic, and this Pn sine n omega t, it will give the amplitude and frequency of the, this is the amplitude part, this is the frequency part is this one. Okay, so it will have the amplitude and frequency of the sine harmonics. So you have to write down also the, what is the H0, what is An and Bn. So H0 equal to 2 by t, 0 to 2 x of t dt. Similarly, A1 equal to 2 by t, 0 to 2 x of t cos n omega t dt. So you need to find out what is A and Bn. So Bn also we have 2 by t, 0 to 2 x of t sin n omega t dt. So this is how the trigonometric form of Fourier series looks like. Okay. Next is your what is sampling theorem? Okay. Sampling theorem states that a band limited signal, okay, of finite energy which has no frequency component higher than that FM, means maximum frequency, that is the of the signal, that completely described by its sample values at uniform intervals less than or equal to 1 by 2 FM, twice FM. So Ts is the sampling time. You can see it will be less than equal to 1 upon 2 FM. Okay, so that is the maximum frequency component of the signal. Second point is that a continuous time signal, band limited signals of finite energy that can be reconstructed exactly from its samples if the sampling frequency at least twice of the maximum frequency present in the signal. So Fs is greater than equal to twice Fs. Okay, so this is our sampling. If Fs is equal to twice Fm, that is called Nyquist rate. Okay, Nyquist rate. Okay, so anyway, you can write this way. Okay, this is the sampling theorem. Okay. Next is state the time scaling properties of continuous time for a series. You no need to derive this. Only write down the what is the time scaling property. So x of t is a periodic signal with time period t. Then x of a t, okay, where a is a constant. So it will be periodic with the time period t by a. The fundamental frequency is a into omega. Okay. So if x of t, the Fourier series coefficient is Cn of period t, and the frequency over here is your frequency is your omega. Okay. So then x of a t, the Fourier series coefficient also the Cn. So both are same, but this period is t by a, and the frequency is your a into omega. Okay. So this is the time scaling properties of the this a is called the scale factor. Okay. So it is t is multiplied with a is a constant. Okay. So this is called the time scaling properties of the continuous time Fourier series. The last question is that find out the Fourier transform of a unit impulse function. Okay. So this is the Fourier transform formula. So you need to find out the Fourier transform this. So del of t. So del of t actually only defined at the when t equal to 0. So if we put t equal to 0, it will be e to the 0, that will be 1. So Fourier transform of this is defined for only t equal to 0. Okay. So del of 0 equal to 1. Okay. So you can del of 0, all values are 0. Okay. So this is e to the power 0, that will be 1. Okay. So Fourier transform of uh, unit impulse function is 1. Okay. So we have seen all the short time question in this video. So in this next video, we will see some of the 6 mark question. Okay. So these are our references. So thank you for watching this video. So if you have any doubt, you can free to ask me in the comment section. So thank you all. Have a nice day.